Okay, good morning. Today we're going to talk about how to solve a system of equations using the substitution method. So at this point, we've done the graphing method and we've been able to graph equations and find out what the point of intersection is if one exists. So now we're going to move on and learn a different method for how to do the same thing. Everything or every equation is not easy to graph, especially if there's fractions involved, if there's larger numbers. We're also limited by the size of the graph. What if they don't cross, on the graph if you're just looking at a 5x5 quadrant rating? So we're going to talk about substitution. This is doing it algebraically, and you should have gotten this in your Google Classroom. So again, when we're done with this, I'm going to have you make a copy and save that in the folder that we should have created on our drive when we did the notes for graphing or volume, one of the two. But anyway, go ahead and put your name on here and your class hour, because you're going to save a copy for yourself as well as turn it in for a grade. Then how are we going to solve this? So we're going to talk about steps. So here we're not going to have graphs at all. We're going to deal with everything algebraically, the equations. So let's go ahead and put in what we want to do. So first thing we're going to want to do is to solve. I'm going to bold this, make it easier to see. Feel free to be creative with your fonts, your colors, whatever you want to do. I'm going to put these in blue. We want to solve one. In for you. Solve one of the equations. Ooh, too much. Okay, I think that's going to be as good as gets. Solve one of the equations for one of the variables. So what this means is we want to isolate either x or y. So remember, isolate means to be alone. So we want either an x or a y by itself on one side of the equal sign with everything else on the other side. And we only need to do that for one equation. If it's done for both equations, that's okay. But if we have to change something, we're only going to do it for one equation. So then after we have that done, we're going to want to substitute in being picky here, but substitute the expression from step one into the other equation and solve for the variable. I'm going to put 5 steps. So far what this looks like is we've taken one of the equations in the system, because remember there's 2 equations in the system, and we've gotten either an x or a y by itself in one of the equations. In second step, substitute the expression from step 1. So when they talk about the expression, they're talking about what is on the other side of the equal sign from the variable you just isolated. That's your expression. And you're going to take that and put it into the other equation that you didn't isolate something in. And then at the end, when I say 5 steps, remember our 5 steps for solving equations: distribute, combine, rewind, solve, and check. So we're going to use those steps to solve it. So once we have this complete, we're basically just solving a multi-step equation. Okay? That's why we did that review practice on multi-step equations before we started these notes. So our third step, we want to substitute the answer from step 2 into either of the original equations to solve for the second variable. And again, we're going to use our 5 steps here. We're going to actually start down. We're going to put number 4 too. We're going to say substitute the coordinate point into an original equation to check your work. Go out, hit back in. I'm going to grab this text box, just move it down there so that it includes all of that. Just moved it up just a little bit so it all fits. Okay, so step 1, we isolate one of the variables in the equation. Step 2, we're going to take that information, variable on one side, the expression is on the other. We're going to take that expression and substitute it in to the other equation, and we're going to solve using our 5 steps for solving equations. When we do that, the purpose of that is when you're looking at a system, you have 2 variables in these equations, and we are trying to make it so that we make a 1 variable equation because we know how to solve that using our 5 steps. Then once we have the value for one of the variables, right? We solve for x or we solve for y, it doesn't matter. We get the value for one of them. We take that value, we substitute it back in so we can solve for the other or the second variable. So if we solve for x first, then we still need to find the value of y. If we solve for y first, we still have to find the value of x. So let's look at this example. Y equals 2x plus 5 and 3x plus y equals 10. Step 1, solve one of the equations for one of the variables. Isolate either x or y. So just looking at these, in equation 1, y is in fact already isolated. It's already by itself. And when I say y by itself, I do y and it has to have a coefficient of 1. Remember, I don't see the 1, but it's still there. So y equals 2x plus 5. 2x plus 5, therefore, is going to become our expression that we're going to use in step 2. And then we have the second one, 3x plus y equals 10. So I'm going to take this expression, 2x plus 5, and substitute it in. So what does that look like? I'm going to open that up. I'm going to bold it. Do some Times New Roman. I'm going to do this one in a turquoise. So I'm going to put a 1 here because step 1 is already completed for us. Where do we see that? We see it when we see y equals 2x plus 5. Okay, step 2, substitute. So I'm going to take y out and put the expression in for it. Because remember, when you substitute in, right, think about playing a sport. Substitute means one person comes out and another person goes exactly in their spot. So I am going to, because I know y is equal to 2x plus 5, I'm going to take out this y and put that value in. So I'm still going to have 3x. Still going to have the plus sign. And now instead of the y, I'm going to put in 2x plus 5. And that's still going to equal 10. So if I told you that the value of y was 2, you'd be able to put a 2 in there for the y. But the value is actually 2x plus 5, so I got to put that whole piece in there for the y. Now I have an equation that I can solve. I can solve this for x, which is what I'm going to continue to do in step 2. So I have 3x plus 2x plus 5. I just put that in parentheses so I understood what I was substituting in. But in reality, I don't actually need those parentheses since it's not being multiplied by anything in front. I'm going to combine like terms. 3x and 2x are going to give me 5x. So I have the 5, still equal to 10. Now I'm at the rewind step. I'm going to rewind this positive 5 by putting a negative 5 on both sides of the equal sign. Actually, let's see. There and bring this back so it like lines up all nice and pretty. I'm sure some of you guys are finding out Miss a little OCD. And now when I do this, I can see 5x is going to be left because nothing's going to disturb it. Then 5 plus negative 5 is going to cancel out. That's going to give me a 0. And 10 plus negative 5 is going to give me 5. So I'm left with 5x equals 5. I'm going to divide both sides by 5 to get rid of the coefficient in front of the x. Remember, I want to know what the value of 1x is. And 5 divided by 5 is 1, so this is 1x. I'm just going to write an x equals, and 5 divided by 5 is 1. So I now know the value of x is 1. Now I have to find the second variable. So I'm going to come up and just like move over. So step 3 tells me to substitute the answer I just got, x equal 1, into one of the equations. Doesn't matter which one I choose. I'll actually show you what both of them look like. If I substitute it into the first one, I'd have y equal to 2 times 1 plus 5. Put 3 over here for step 3. I just made one big text box, so that's why I have to like use my cursor and kind of like come down instead of entering. So now y equals 2 times 1 is 2, plus 5 is 7. Had I chosen to put it in the other equation, we do this in a different color so we know it's an alternate. It would be 3 times 1 plus y equals 10. You know 3 times 1 is 3. So 3 plus y equals 10. I have to subtract 3 from both sides. Get y by itself. I'd be left with y equal to 7. So you can see it doesn't matter if I use the first equation or the second equation, I would still get the same value for y. And step 4 asks me to go ahead and check my work. So I can use either equation. So step 4, I now know, based on my answers, x is 1 and y is 7. So actually, before I do step 4, I've proven that the answer, or the answer right now, is x is 1, y is 7. Our coordinate point is x and y, so my answer is 1, 7. So step 4 asks me to check my answer. So I'm going to plug that into the first equation. Again, it doesn't matter which one I chose. And I'd have 7 equals 2 times 1 plus 5. And I can see 2 times 1 is 2 plus 5 is 7. So this, in fact, is a true statement. Therefore, my answer of 1, 7 is correct. Example 2. We have 3x plus 4y equals 8, and x equals 16 minus 4y. Here, again, they've already isolated. They've already completed step 1 for us. They've isolated the x. I'm going to choose a different color for this one just because, you know, I want to do things different. I'm going to choose this nice orange and bold it. So step 1 is completed for us. We know because x equals 16 minus 4y. So I can move on to step 2. I'm going to take that expression, 16 minus 4y, and substitute it in for the x in the other equation that I hadn't touched. So 3 times 16 minus 4y plus 4y equals 8. So if you're following my cursor, you can see I took this expression and I substituted in right here for this x. So this x and this expression are interchangeable according to this because x is equal to that. So I can take the x out and put in its other value, what it's equal to. Now I'm going to solve using the 5 steps. So I have to distributive property. 3 times 16. I'm going to write all the steps out now, but if we have to do distribution later, I'm just going to do the math. Minus 3 times 4y plus 4y equals 8. 3 times 16, 3 times 10 is 30. 3 times 6 is 18. Put that together, you get 48. Minus or negative sign. So if I feel more comfortable, I can do plus a negative. 3 times 4 is 12. So I'd have 12y plus 4y equals 8. So that's distributive property. So distribute, step 1 in the 5 steps. Step 2, combine like terms. 12y and 4y have the same variable, so they can be combined. So I'd have 48. Negative 12 plus positive 4 would give me negative 8y. equal to 8. I want to isolate the variable term, so I want to isolate this negative 8y. So now I'm in my rewind steps. I'm going to rewind a positive 48 by putting a negative 48 on both sides of the equal sign. Remember, the way you undo something is you do its opposite mathematical computation. So 48 minus 48 is going to be 0. Negative 8y, just nothing, that wasn't touched, so that comes down. Equals, and 8 plus negative 48 is going to be negative 40. I'm going to divide both sides by negative 8 to isolate the y. And I'm going to get y equals negative divided by negative is going to be a positive, and 40 divided by 8 will be 5. So step 2, did all that to get y equal to 5. Coming back over here. Step 3, take what I know. I know y equals 5, and I'm going to substitute that back into one of the original equations. So it doesn't matter which one I choose, but I am going to choose number 2. And the reason is because I want to know the value of x. Here, x is already isolated. If I put y equals 5 into the first one, which I certainly can, I would have a full equation to solve. I'd have to, move this over here and then divide by 3. So there would just be less math work if I put it into the second equation. So I'm going to have x equal x equals, keeps on making that capital, drives me crazy, but I'm just going to leave it be. 16 minus 4 times, I just found out the value of y is 5, so I'm going to put that in. So I just use the arrow button down. So x is going to equal 16 minus 4 times 5 is 20. So x equals negative 4. So our answer is the coordinate point. Remember, x comes first. We know our ABCs, so negative 4 and positive 5. That is what I have found the answer to be. Meaning that if I put these two equations, if I had graphed them, my two lines on the coordinate graph would cross over, intersect at this point, negative 4, 5. And of course, I'm going to check my work. As I get really good at this, I could just check my work in my head. But here I'm going to substitute it in. And I'm going to use that first one since I didn't use it in step 3, the 3x plus 4y equals 8. I'm going to substitute this answer in here because it kind of like helps me check to make sure I haven't made a mistake. So 3 times negative 4 plus 4 times 5 equals 8. So 3 times negative 4, a positive times a negative is a negative. 3 times 4 is 12. Plus 4 times 5, 20, equals 8. And that is a true statement because negative 12 plus 20 equals 8. I can even write it out if I want to. I can put 8 equals 8. Therefore, that's true. Therefore, my answer is correct. Okay, moving on to the third one. We have x plus 4y equals 9 and x minus y equals 4. So here we don't have anything isolated for us. We have to do that work. Okay. Looking at this, I want to find ideally a variable to isolate that has a coefficient of 1. right? So here, this x, it has a coefficient of 1 because I don't see a number in front of it. I assume it to be 1. This y's coefficient is 4. This would be harder to isolate because that means I'm going to have to divide by 4 at some point. Down here, x, again, coefficient of 1. Here, negative y. That has a negative coefficient of 1, but that might be kind of easy to undo. So I'm going to go with the second equation because I could actually isolate x or y here. But I'm going to isolate x because to move the negative y will help me out. It will actually make it from a positive to a negative. So again, I'm just going to erase that input work part. I'm going to use my Times New Roman. Colors, colors, colors. I'm going to use this bright purple because why not? And step 1 is not done for us, so let's complete that. We're going to use the x minus y. X minus y equals 4. And I have to isolate that x, so I'm going to add a y, right? Because remember, negative y means that it's plus or minus a negative y. There's a negative 1 in front of that y, the coefficient of it. So plus y, both sides of the equal sign. Remember, I've got to do everything. Do one onto one side as you do onto the other. That's the golden rule. So now I'm going to be left with x, negative y plus positive y cancels out, equals y plus 4. And I would get in the habit of always starting like with your variable terms, unless it's a subtraction. That might make it easier to do it the other way, but usually you want to have the variable first followed by your fixed number. So now I know that x is equal to y plus 4. This is my expression that I'm going to use in step 2. I'm going to take this, I'm going to take out this x, and I'm going to substitute in the expression that I just determined. So I'm going to have y plus 4 plus 4y equals 9. And there's no number in front of this parenthesis, so I don't actually need it. So I'm just going to do y plus 4 plus 4y equals 9. Just getting in the habit of taking things out of my parentheses. That's step 1 when you distribute, right? Get rid of the parentheses. So now I have 1y plus 4 plus 4y equals 9. I'm going to combine like terms because 1y and 4y will give me 5y. Equal to 9. Of course, I want to solve for the y, so I'm going to get rid of my fixed number first by subtracting 4 from both sides because you have to undo all of your addition and subtraction before you can undo multiplication. I mean, you don't have to, but it just makes your life easy, I should say. So 5y equals 9 minus 4 is 5. Divide both sides by 5. Here we get y equal to 1. Move my text box up a little bit, make it just a little bigger so it includes that. So y equal 1. So now we're on to step 3, solving for that second variable. Remember, we need to find the coordinate point. So just finding the value for either the y or the x alone, that's not good enough. So I can substitute this into either equation. I'm going to put it into the second one, see how that works out. So I'd have x minus 1 equals 4. And one of the reasons why I always put, like when I'm substituting in, why I always put in the parentheses is so that if I go back and look at my work, I know that's something I substituted in. Also, I don't drop signs. So if this was a -1, subtracting a -1, sometimes that one of those negatives winds up getting lost in translation. So it's just easier to put it in parentheses so you can see what you're going to have to do. So I'm left with x, make this a plus, -1 equals 4. I'm going to add 1 to both sides. Remember, if you're someone that struggles with those integer rules, make every subtraction a positive and change the sign of the term afterwards. So x equals 4 plus 1 would be 5. So I just found an answer of x is 5 and y is 1. I'm going to check my work and use the equation that I didn't use in step 3. So in step 3, I used the equation x minus y equals 4. That's one of the original equations. So I'm going to take my answer and substitute it into the equation I didn't use. So we would have 5, that's the value of x, plus 4 times 1, 1's the value of y, equals 9. So 5, 4 times 1 is 4, equals 9. I believe that is a true statement. 9 equals 9. So we did this correctly. Okay. So when you were graphing, you should have seen that there were 3 different types of answers you can get. You could get one solution, which is all of the cases that we just did, where we come up with a coordinate point where if we were graphing it, our 2 lines would cross over. Or basically what we're saying is that if the input is 5 in both of these equations, input being x, that the output, the y value, would have to be 1. That's what we're saying in both of these equations, okay? That's what that coordinate point or the answer means. Now we're going to go on and we're going to look at what happens when it's not the traditional answer of they cross over. What if they never cross over for different reasons, right? So we're going to look at these two. We have x minus 2y equals 7 and negative x plus 2y equals 7. So we're going to still do our work here, our input to work. We go back to blue, because I like blue, because I'm a falcon. So step 1, I have to isolate one of these. I see this x right here is the only variable term that has a positive 1 as a coefficient. So that's going to be the easiest to isolate. So I'm going to start there. X minus 2y equals 7. And just disregard the fact if x or y's get capitalized, they're all should be lowercase letters, but they love to autocorrect on here. So I'm going to add 2y to both sides. And when I do that, I come up with, I didn't do anything to the x, so it's by itself. The 2y, negative 2y and positive 2y will cancel out. And the other side I'll have 2y plus 7. Okay, so x equals 2y plus 7. So now that's going to be my expression. So I'm going to move to step 2. And I'm now going to take out this value of x and put in 2y plus 7. Now notice there's a negative in front of that. So I need to have a negative or a -1 in front of that parenthesis when I'm substituting in. So this becomes 2y plus 7. And then I also already have a 2y over there equal to 7. So do your distributive property. -1 times a positive 2y would give me negative 2y. A -1 times a positive 7 would give me negative 7. I already had positive 2y. That just comes down equal to 7. So combine like terms, negative 2y, positive 2y. Those are additive inverses, or they're opposites. So they're going to actually cancel each other out, leaving me with a negative 7 equals 7. Is that true? Well, if you think it is, how about I just owe you $7 and you can give me $7 and we'll call it even, right? Because this is a false statement. And if you remember when we were solving just multi-step equations, we were taught that if the variable terms drop out, we're going to be left with a no solution or an all or infinite solution problem. The difference being that a false statement would mean no solution. A true statement, if this said 7 equals 7, would be an infinite solution. This is going to be no solution. Okay? If you were graphing this, when do you have lines that never cross each other? Goes back to those race scenarios we talked about. What if Antoine started running from the start line, whereas Amir started 3 meters ahead of Antoine, but they both ran at the same pace or the same speed? Antoine would never be able to catch Amir because Amir already had a head start and they're running at the same exact pace, right? So in that case, we would have parallel lines. Why? Same slope, different starting point, or y-intercept. That's what it looked like on a graphing situation. And here we can see we come up with our variable terms get knocked out or eliminated, and we're left with just negative 7 equal to 7. Let's move on to our next problem, or our last problem on this page. Almost done with the work for today. Get rid of that. I really like that purple, so I'm going to go back and use that purple. You know me, I like things colorful. So step 1, we have negative 16x plus 2y equals negative 2, and y equals 8x minus 1. So lucky us, step 1 has already been completed for us. Bold that, looks better for you. It's been completed for us, and because we have y equal 8x minus 1. Okay, so step 2, let's go ahead, take our expression of 8x minus 1, right, our expression, and this is going to replace the y, right? Why? Because y is here. This is equal to y, so it can replace y, because these two things have the same value. So negative 16x plus 2, then parenthesis, I'm putting in 8x minus 1, where y was, and it's still equal to negative 2. So I'm going to have to do all my steps. I'm going to have to distribute. Negative 16x, though, that just can come down. Then 2 times 8x. 2 times 8 is 16, so bring down your x. And 2 times negative 1 would be negative 2, so I'm going to add a negative 2. That's equal to negative 2. Combine like terms, I have negative 16x and positive 16x. They're additive inverses again, so they eliminate each other. And I'm left with negative 2 equals negative 2. And that is a true statement. And so when we have true statements, that means that, going back to the race, this would be Amir and Antoine start the race both at the start line, so no one gets a head start, and they run at exactly the same pace. Now, if they're pretty much the same size. So if you were watching the race at the angle, like you're looking not straight at their face, but you're looking at their sides, essentially they would always be at the same place. So it would be like you're only seeing one body. So on a graph, we would only see one line because the lines would actually be on top of each other. Okay, so here we're going to have an infinite solution. And that means if I was graphing this, we only see one line because they are exactly on top of each other. So infinite solution, if it would let me draw a symbol, shapes. Let's see if they have an infinite shape on here. I don't think they do. Nope. So, but remember that's set sideways, or that 8 that's laying on that side. That's what an infinite solution is. So that is how you use substitution to solve a system of equation. Okay, you are using your solving equation skills, your 5 steps: distribute, combine, rewind, solve, and check, to help you find the value of both the x and the y variable. And those together make your coordinate point that are either going to be where your two equations would meet on a graph, where they intersect, where these values basically make true statements in both equations. Or you're going to have a scenario where maybe everything's equal, where your variable terms will drop out and you'll have a true statement that's infinite. Or your variable terms drop out and you have a false statement, and that's no solution, meaning that those lines would never cross over, right? They don't have any answers in common. So if you have questions, please let me know. So remember, the last thing I told you guys to do is that now that you're done, before you turn it in, make a copy for yourself, okay? So what you want to do is you want to go here and you want to go File, make a copy of the entire presentation. And then here is, for me, that's where the folder would be, where it's going to go to. But this copy, I want to actually remember put in that folder that we made in our drive called Math Notes. So I'm going to go back out of where I had them. I'm going to go back to my main drive. That's where yours should be. And it should be in a folder that we called Math Notes. Maybe, did I make it Egan Math Notes? Either way, you guys should have one that says Math Notes, because we made that the last time we did this. I'm going to go back and check. Groups, 6th grade math resources. Oh, here we go. 8th grade math notes. I had to make it fancy. You guys could just call it math notes because you know you're in 8th grade. And I didn't make any things inside of it. But you can see we had put the graphing one in there. So I'm just going to choose that folder, hit select, hit OK, and it will actually produce another copy of the notes for me. And it's going to say copy of the notes. Yours will say copy substitution method. Maybe erase this part of it and put your name. But either way, this is the copy, right? You don't need to worry. That's not what you're going to turn in. Go back to the one right next to it. And here you'll see your turn in button. I don't have one of that because I'm the teacher. And you will turn in your work and show that you've done the notes. Hope you guys are having a great day. Remember to continue to work hard, because all of this stuff you guys need for high school. So some of you guys need it to ensure that you're going to pass the semester so that you don't have to go to summer school. So hope you guys are doing well. Miss you. And you can do this. We can do this. Have a great day.